Now, please, my friends, help me welcome to the stage the founder and CTO of OriginTrail. It's Branimir Rakic. Forward, back.
Hey, everybody. Testing, 1, 2, 3. Okay, you should hear me, right? Awesome, awesome. Thanks for the kind intro and thanks for sticking around. I have so much to say in the 20 minutes, so maybe it's going to be a little bit quicker. But so please remind me of the time. But yeah, I'm going to cover a broad strokes over a bunch of interesting topics at the intersection of AI and decentralization. So I'm happy to chat about more in-depth topics outside or over a beer. I was introduced, I'm Branimir, one of the founders and CTO behind Project OriginTrail. We've been around also for quite some time, like Energy Web. We actually started OriginTrail 2013 as a centralized closed source project, and we became decentralized open source in 2017, launched on Ethereum. We're currently in version 8 of OriginTrail Decentralized Knowledge Graph, and we've been implementing it in the real world ever since we started, basically. So we have partners such as Swiss Railways who are using it for many years now, running nodes and tracking all their stuff, basically, on OriginTrail. We also have partners such as US retailers, Walmart, Target, Home Depot, who are securing over 40% of US imports through security audits, actually, on their platforms. Partners in pharmaceutical industries and so on. The ecosystem is growing incredibly, and lately a very interesting solution for deepfakes launched by a new company, which I'll mention a bit later. That's a bit of history of OriginTrail. I'm going to give you what we're actually tackling with the technology. So obviously, we are in the age of AI right now, and in 2025, we're seeing a growing adoption of agents, and basically this is a projection of where that market will go over the next 5 years. And obviously, pretty much everybody now today is pitching some sort of AI agent, which makes sense. I mean, it's a technology that is very promising. However, there's a bunch of problems with the current AI. And as you can see in these couple of examples I'm sharing, the current AI, specifically generative AI, is very tricky because it's very unreliable. We all know about these problems of hallucinations and so on. So you can just see these two weird photos. They say it all, basically. They're not just hallucinating, so there's a bunch of other problems that we are kind of intimately familiar here. Data ownership and intellectual property is one. Then we have, obviously, centralization. Companies like Palantir gobbing up all the data in the world and actually using knowledge graphs under the hood, which I'll talk about in a bit, but using it in a misappropriating way and for, well, questionable outcomes. Bias obviously comes with that, and model collapse is another very big problem. As now that we're generating all that junk with AI, that junk goes back into the training data, and now the training data is shittier, and then because of that, we get something called model collapse, which means that the models are becoming worse. The more you train them, they're supposed to be better, but actually now you're training them with more junk. So therefore, those agents that we're hoping to go up and to the right are also going to, they're not going to be immune to these problems. So what actually is the way forward is presented by one of the Turing Award winners, Richard Sutton, and folks from Google DeepMind, who say basically we're entering an era of experience. We were just now in the era of human data. We were stuffing all these data into these generative AI models, and we came with some pretty interesting results. I'm not saying here LLMs are junk. They're very useful. I'm pretty sure people here use ChatGPT or something similar all the time, right? But if you want to really get into that adoption and all the value that we want, we need to make them autonomous, reliable. So in order to do that, we're actually exiting this era of human data as we speak. We're getting into the era of experience, which is where these agents will collect experiences by interacting with the world, and through those experiences, storing them in some sort of memory, they will actually be able to learn like we do. So not by us, feeding them the whole stack of books in the head, squeezing it in, which is current trading, but actually just letting them do stuff, And then as they do stuff, they will get feedback from the environment, and therefore they will learn. So we subscribe to this path of AI forward. So it's been quite obvious for some time that just training and scaling training on LLMs is not going to cut it. But this will. This era of experience produces ultimately infinite new reliable data from the environment. So technically, when you think about agents, you should think of three things. There's some certain systems or domain of agency where they are active. That can be anything from Discord to railway system. So anywhere where they interact with something in the real world. Then we have some AI models, and it doesn't have to be Gen AI models. It's broader than that. And then we have a notion of memory, which is the most interesting to me, and I will dive deeper into that today, because this memory is the key thing. You don't want to memorize everything in the model. And if you listen to perhaps to one of the latest podcasts with Andrej Karpathy, the famous AI genius behind Tesla and OpenAI, he says that we really need to split models and memory. He's absolutely right in our opinion. Having that said, what kind of agents we're really looking for is those that don't hallucinate, wherever the memory comes from, this thing that they are reading from is actually has provenance, it has some sort of reputation of a source. We want fair value exchanges, obviously, and at the same time with that, we need to have a system that is connected, multiple entities interacting together so that they can keep their data ownership and ultimately privacy as well. We don't want to build a panopticon out of AI, right? So very briefly, what really comes kind of as a solution here is this combination of generative AI, the creative one, which is kind of like our left brain, and the factual one, which is kind of like your right brain. And at the intersection of these two things, we actually get the properties that we want. But let me do a mini exercise just to wake you up. So if I call you, and I'll start with you, think of a word, say it out loud, and then the next person you point to just says the next word. Let's try to make a sentence together. So, okay, I'll start actually. I'll start as, let's say, sub0.
Is amazingly, and now you point, a great sub0 is amazingly a great conference.
Yeah. So, bravo, great job, guys. This is a plausible sentence that basically shows exactly how an LLM works. So it basically has a sequence of words, and then it comes up, it hallucinates the next word, like you all did here, basically. So this is all they do. They just do it really well because they have a shit ton of data inside, and they can predict what they call the next token, but basically it's the next word. So this is what you did right now. So congrats, sub0 LLM. Basically what you did was very creative, right? But it doesn't have to be a fact. Maybe it's not a great conference, though it is. But basically what we want is, also we want this side. We want deterministic, reliable, rule-based logic. And that's where OriginTrail decentralized knowledge graph comes in. When you combine it with a creative side, you get the power of LLMs together with it. So you get all of this natural language interaction and all of this positive side, but rooting it into the rules and the deterministic logic on the DKG side. So what does this really look like is a knowledge graph. And what is a knowledge graph, you might ask? If you have never run into it, it's actually a branch of AI, an older branch of AI called symbolic AI, which has certain really interesting properties. It basically is about connected data. And because it's connected data, it's semantically rich data. So there's a lot of context in there. And with that context, you have a flexible data model. So it's Google, when they invented the term knowledge graphs 20-something years ago, they said that they're things, they're not strings. So it's all about these entities and this subject-predicate-object model. There's a bunch of standards there. And this is the AI that all of the big companies have been using since forever and are still using today, including Palantir, for example. So the DKG, OriginTrail, basically brings this into the open source. Another way to think about this is you can think of entities and they have certain relations in between them. If you do this well enough, if you enrich it well enough, you can do all kinds of interesting things like symbolic reasoning. For example, we all remember this example from school. Socrates is human, and a human is mortal. Therefore, Socrates is mortal, right? It's super simple. If this, then that, right? Well, imagine that on a huge knowledge graph and thinking about proteins or pharmaceuticals or even trains. We've done some very, very reliable reasoning based on these rules because you can literally encode physical rules into the knowledge graph. But yet again, you can also combine it with this neural AI. And you get to this really interesting concept of what we call knowledge assets. These are basically the key primitive in the decentralized knowledge graph, which actually root their existence in the blockchain, so you can own them. You can own the data inside, and the data can come in multiple forms, both the neural and symbolic form. And for each of the data point inside this graph, you have certain cryptographic proofs that allow you to, for example, not just prove that you own it, but also have the ability to prove that a certain piece of information is part of a knowledge graph, of a larger knowledge graph, which is very useful as inclusion proofs. So having that said, basically that stack becomes, in our worldview, a bit like this. We have blockchains at the bottom, which provide the provenance and identity and ownership, trusted execution, obviously, and consensus-based system. And then we have the graph, which is a non-consensus-based system. It basically leverages consensus from the blockchains. And that's where all of these knowledge assets are sitting. So basically today you can build memory on these two. Very reliable memory that executes smart contracts or whatever, basically consensus enforced code, with the knowledge that has high structure and rule-based reasoning. And then you combine it with models on top. And all of a sudden you get a model, you had an agent that is able to leverage all of the basically the rule-based, verifiable, reliable bottom two layers. How much time do I have left? 4 minutes, beautiful. I'm about to finish. Another way to look at this is like this. So the knowledge graph, actually the decentralized knowledge graph, lives on different devices. So you can run these DKG nodes either on the edge or on the core. And on top of them, you would have certain co-located agents. And with that, you can also build something very interesting called the paranets, which is shared knowledge graphs, which is really cool because, for example, you could build a shared knowledge graph like Wikipedia is doing. It's a shared knowledge graph, essentially under the hood, and you could incentivize the creators with something called knowledge mining rewards, which are issued in the Neuro token, the token of the blockchain called NeuroWeb that we have launched on Polkadot quite some time ago. And this is not just us saying, there's a lot of research coming out, and these are just a bunch of papers that came out recently that are at the intersection of knowledge graphs and AI and really neurosymbolic reasoning. So I encourage you to take a look into this field if you're into AI and reliable AI per se, and also to look into NeuroWeb because it can help you bootstrap your project with literally knowledge mining incentives. So if you're looking to build a neurosymbolic system, you can do so with the help of NeuroWeb community, who is happy to support useful projects with certain token incentives. Last but not least, if you would like to try this out, this is all very bleeding edge stuff. A hackathon is a really good way to do so. So we have just launched a global hackathon sponsored by OriginTrail, Humanitech, and Polkadot, which you can basically jump into right now, and it lasts until December 3rd, I believe, which is when we have a big conference in Ljubljana called the DKG Con. And obviously as a hackathon participant, we're happy to have you join us. You can scan that QR code to find more about the hackathon, but I'll just very briefly introduce what are the topics of the hackathon, and this is my last slide, if that's okay. Beautiful. So we're doing essentially 3 things in a wild card. The first one is we really want to see how we can embed or discover how truthful these systems are. And we are excited that we saw Grokipedia go up. So Grokipedia versus Wikipedia. The idea is to connect those two and use the knowledge graph to compare for bias, for truthfulness, and experiment in this area. So that's one topic we're looking into. The other one is decentralized community nodes. So think about a social graph where, let's say on crypto Twitter, we have a lot of content, so we're able to create community nodes just like we've seen on Twitter, but obviously with the power of the technology we are building here. And third one is social graph reputation. How can we leverage these connections in the graph and all of the rich context to actually compute our own reputational algorithms rather than Twitter, for example, basically filtering out in their own way and having an algorithm somewhere under the hood. We as a community can build actually our own. So what we're looking for here is to basically, for builders who are interested to experiment in these areas and use the DKG. Basically, you would download the DKG node. OriginTrail DKG node is a MCP-enabled decentralized system, basically, that connects to a blockchain, in this case, NeuroWeb, and you can basically start building very quickly. It's actually quite easy, so if you're interested in tapping into these kind of projects, I'd be also happy to chat about that more on the outside, but I understand I'm kind of done, so I want to just finish with a quick quote by another Turing Award winner, Jan LeCun, who said that if we want to train an AI system that is reliable and global, it has to be crowdsourced, and all humans need to contribute to it. So I invite you to contribute to it, and thank you for your attention.